So hello everyone, this is the Promotor channel. Today we're going to take apart this engine. This is a Volvo engine. It was taken out of a truck like this. Now the engine model and technical specifications will appear on the screen. So, not long ago I featured a Volvo engine repair on my channel. Well, that engine was a bit simpler. Actually, not just simpler, but probably an older model. This engine is already more modern. As we can see, it already has a unit injector installed. We can see that there are 4 valves per cylinder here. Also, the main difference is that there's a single cylinder head for all 6 cylinders. So it's huge and heavy. I don't know how much it weighs, probably more than 100 kilograms, maybe 150 or even 200 kilograms, I think it's about that. And we can also see that we have an overhead camshaft here. The camshaft is mounted on the cylinder head. So there are no push rods on this engine. And the rocker arms are operated directly by the cam lobes. Cam lobe for the intake valve, cam lobe for the intake valve, well, and also cam lobe for the unit injector. Right, these are the main differences that stand out right away. And now, as we go along, we'll take it apart and see what else is different about this engine. So, compared to the previous Volvo engine, this engine has been on my list for a long time. It's probably been about 6 months since the customer made the down payment, and only now he was able to come for repairs. He came from St. Petersburg. We have all the standard work ahead of us with this engine. That is, we disassemble and inspect it for defects. We handle some tasks ourselves and outsource others to third parties. We also order spare parts. I assemble and install the engine in the truck. Well, and then the startup. The startup will probably be done in the truck. Basically everything is standard. So we remove the engine from the truck. I've already washed it. That is, we took it to the car wash. I've already washed it as much as possible. I spent several hours here cleaning it. I tried to get the dirt out from all the hidden spots, so to speak. Well, the engine was covered in a layer of dirt and dust. I spent 2 hours cleaning it. Well, basically it's more or less okay now. I can work on it. I have access to the bolts and so on. Before that, of course, it looked much worse. So, what do we know about this engine? It has 2,400,000 kilometers on it. That's according to the customer. The customer has been working with this vehicle since 2006, so that's already 18 years, 2,400,000 kilometers on it. And the engine hasn't been repaired yet. Well, now we're going to take a look at all of this. We're going to see everything. I'm really interested to see what happened to the engine over such a long period and such high mileage. Now we're going to take everything apart and check it out. Alright, I'm starting to disassemble the engine. But first I'll insert some footage that I've already shot. There's not much of it. As for the truck itself, what it looks like, there's footage of the container, how we remove the container from the frame. I also have footage of how I removed the gearbox and so on. Now I'll insert the footage that I've already shot. And then we'll start the disassembly. Oh, and I also want to mention that we removed the valve cover while it was still on the truck, because there was no lifting eye. But we found this lifting eye at the junkyard and bought it. There was no other way to hook up the engine. We were already thinking about making some kind of homemade lifting eye for these bolts and hooking the engine to it. So as I said, we bought this factory-made loop, the eyelet, and attached it. Well, in any case, we would have had to remove the valve cover because on this side the chain was attached to 2 bolts like this. And basically, when the hook was attached to this chain, the cable was pressing right against the valve cover itself. And since it's plastic, of course, it would be better to remove it so it doesn't get broken. The engine is big. It's larger in size than, for example, the MAN D2876. It's a large engine and accordingly it's heavier. So this is what the valve cover looks like. The valve cover is just gigantic. I don't know how well you can see it on camera, but for example, you can compare it to my hand. Or for comparison, for example, I have an angle bracket that's 25 cm. Well, that's just to give you an idea of the scale of the valve cover and the overall size of the engine itself. So, what can I say about the engine? We can see these kinds of solid deposits inside the valve cover, for example, right? We can see how much is on the valve cover itself. Also, under the valve cover, we see it on the camshaft, on the rockers, and so on. Basically, everything here is covered in these solid deposits. So, what problems did the customer have with the engine? The main issue is that it has a lot of blow-by. On this side there's a tube coming out and smoke was pouring right out of it, thick clouds of smoke. So, you could say that's the main problem with this engine. It has a lot of blow-by. And, well, there aren't really any especially critical issues. So you could say this is just a scheduled repair for us. As I said, it's time. The mileage is 2,400,000 kilometers. Alright, let's start disassembling, but first here are some clips I've already recorded. Let's go! I want to according to what people write to me, you can't paint over wires, you can't paint over bolts, nuts, and so on. Let me show you. At the factory, everything is done exactly the same way. You can see all the wires, the corrugated tubes, everything is painted over with factory paint. The paint has already peeled off the cast iron in some places, apparently. iProdumo. There are some nuances, but they exist, and my opinion about Volvo engines hasn't changed. Even though I picked the most popular Volvo engine, my opinion hasn't changed. I'm saying it again. Well, this is just the beginning. We'll keep taking things apart and see what else is going on. But after working for several hours with this engine, it's already enough for me to understand that there's no difference whether it was that engine or this Volvo engine. This is Volvo. That's all there is to it. That's just my personal opinion. Someone else might think completely differently. So I'll repeat, I'm expressing my personal.
Third one is well, in general, we need to take it apart, and then everything will become reassembled. I removed the front cover and got the gear tray. Some looks The mark on the flywheel housing.
Oil pump, idler gear. This is the oil pump drive. This is intermediate. This is intermediate. This is intermediate. Well, and from them, the rest is driven from them. Here is the fuel pump, the low pressure pump. Here is the power steering pump. But the other way around, here we have, I think, the power steering pump right here. Good fuel pump. Here we have the water pump, and in this place I think there is nothing else. This is intermediate. Well, and here we have the camshaft drive. Next I remove the oil pump, and then I take off all these intermediate gears here. After
I'm going to remove this protection, this additional plate. You can see we have one bolt here.
day. Well, usually you can disassemble any engine in one day. But that's if you're not filming without all this. Well, usually it takes me about 2 days to disassemble an engine. Well, not full days, because while I'm moving the camera, while I'm doing something there.
Ilas vien iki as it is, because here everything here is in perfect shape. So the bearings are still in principle in quite satisfactory condition. Let's put it that way. Well, etlulara ilnarospivulva imatuitoshkinom. The bearings that are in the cap are definitely in better condition than the bearing that will be in the connecting rod. There will definitely be more wear on the one in the connecting rod, but there's also wear on this one, if we look right here. If you know, so the bearings are still Volvo original ones. I don't see the production date. Well, most likely these are still the factory bearings, because, as I said, the customer mentioned that the mileage is almost 2.5 million kilometers, and this engine hasn't been repaired yet. Given that the customer has been working with this vehicle
since 2006. So it turns out that the person has been working with this vehicle for 18 years and the engine hasn't been repaired yet. We also see another interesting point. We have a composite piston here, meaning the piston skirt is separate from the piston crown. So it is. And all of this is connected by the piston pin. Well, I've worked on engines like this before, but this is the first time on the channel that we've come across pistons like this. That's how it is. So all of this is connected together with a piston pin. The skirt is installed separately and the piston crown is installed separately. And even as far as I can see, the materials are different. This is aluminum and this possibly is even cast iron in the piston crown itself. Yes, well, of course, the engine is just in perfect condition with this kind of mileage, considering that it's almost 2.5 million kilometers. The overall condition of the engine is just, I don't know, amazing. The strength margin on it is just colossal. Here are the pistons, the skirt. The pistons themselves seem to still be in good condition, but the piston rings, and you can see the groove is worn out. That is, the ring is already loose. In any case, we'll have new pistons too. So the cylinder liners need to be replaced and the piston crowns need to be replaced. Well, it would make sense to replace all that and leave the skirt alone. If it's even possible to buy this piston in parts at all. Most likely it's sold as a complete assembly deal. That's why I think we'll have a new piston assembly in any case. Well, The engine is in very good condition, especially considering it has 2.5 million kilometers on it. You could say the engine is just in excellent condition. What kind of work do we have ahead of us? So, first, I need to clean the block. As you can see, the deposits I showed earlier, I need to clean the block, check the seating for the liners, and check the seating for the main bearings. But still, I think that the main bearings we have there is wear in this spot, and also by the imprint of the main cap right here we can see a step. Well, right now the block is dirty. Of course I'll clean all this up, take some measurements, but I think the block will still need to be machined. At the very least, the main bearing seats. Next, we'll have a new piston set. By the way, I want to show you the cleanest water jacket I've ever seen in all my years of work. This means that the engine has been running on good antifreeze. Not once in its entire operation has this engine seen water in the cooling system. And so on. So as you can see, everything is in perfect condition. Well, here the wear is about 0.5 millimeter. You can even see this step on camera. So the liners all need to be replaced. The rod and the main bearing obviously need to be replaced. I think the bearings will be standard size because as far as I could see there are no issues with the crankshaft. So the Volvo crankshaft had visible scratches and about 4 or 5 hundredths of wear, but with this crankshaft there are no such issues. I'll also be removing these plugs cleaning the channels, blowing them out and washing them. The fuel,
repair. As for the cylinder head, we're disassembling it.
we'll figure it out as we go. So we also need to clean the gears, check the bushings. Each gear has a bushing. Also, check the shaft. Well, for now, everything looks fine visually. But, as I've said many times before, you need to clean everything first. And only when the part is clean should you inspect it for defects. Next, I don't think there will be any issues with the camshaft either. I took a visual look at the camshaft and basically everything looks fine. I'll clean it as well, measure it. It will be replaced. We have bearings. As I already showed, we don't have bushings here, but we have bearings. By the way, it's a very interesting solution. I've never seen anything like this on any engine, at least not in my experience. I've never seen a camshaft mounted directly on bearings like this. So I think there won't be any issues with the rocker arms either. I'll clean everything, blow it out, and we'll put it all back in place. I'll take apart the oil pump and check it, especially since the housing here is aluminum, which isn't very good. Well, in general, we'll take another look at the oil pump, and as for this pile of spare parts, we'll clean everything and check everything. For the front cover, we'll need to buy a repair kit or rather, a kit specifically for installing this cover. Peaks. It fits onto the block without any guides, and that means the position of this cover determines the clearance in the gears. If you move it, let's say, to one side, then one of the intermediate gears will get pinched and the other will have a lot of play. So this is a very important point, Dad. We'll try to find the factory guides specifically for installing this cover. Well, if it doesn't work out, then I'll have to think of something. Maybe make something homemade, maybe machine something myself, and so on. But when assembling, you definitely need to pay attention to this point. And also another feature of Volvo engines is that all these covers are installed without a gasket, just with sealant. The engine I worked on before was the same way. The intermediate plate was sealed with sealant IM. Then this cover with sealant IM. And the rear housing also with sealant. Well, for example, the valve cover and the oil pan are installed with a gasket. So we'll also take apart the compressor and check it. There might be minimal repairs, like replacing the valves and piston rings, just like we did with the previous compressor. But maybe there will be a more major repair, or we might even need a completely new compressor. We'll get to that later. We'll see about all of that. As for the electrical equipment, we have the starter, the alternator, and the wiring. All of this will probably know. Go in for repairs, at least for inspection. And after the check, we'll decide what we'll do with it. I also want to say a few words specifically about the engine itself. The engine is very interesting, especially since it's nice to do something different for a change. I'm even curious myself to see its design. And there are a lot of solutions here that I haven't encountered in my practice before. The engine is interesting in that regard, and also the engine is very reliable. We can see its excellent condition even with this kind of mileage. And also the engine, I wouldn't say that's my opinion. So I'm starting the assembly. The block has been through machining. The main bearing seats were line bored, and that's basically it. We didn't touch the cylinder head mating surface, and we also didn't touch the seat for the sleeves. Everything is fine here. Now, about the main bearing seats, the machinists said we removed the engine just in time, Struski, because otherwise the bearings would have spun, and then the block would have been 100% scrap. Of the block got here yesterday, so what's my task now? Well, I need to work on the block some more, get it ready. I can still see some metal shavings here. This is how much there is. Remove all the shavings, then blow it out, clean out all the passages, remove whichever plugs need to come out, then reinstall the oil jets, and then we'll start the assembly, meaning we'll install the crankshaft, the camshaft. And this engine is installed in the cylinder head, so there's not much work to do with the block here. Well, I mean, you don't need to change things. Like the farmer installs the camshaft and so on. So we installed the crankshaft, install new sleeves. The piston group is basically everything as we go. So all the spare parts have already been purchased. I already have all the parts. The engine was disassembled about 3 or 4 weeks ago, so almost a month. And as you may remember, this engine is very dirty inside. I mean, probably the dirtiest engine of all the ones I've ever someone else too. So next I'll be installing the crankshaft. I've prepared the crankshaft and polished it. First, I washed it in diesel fuel because, as I already said, this is the dirtiest engine I've ever seen. There's a lot of this greasy, sooty, burnt residue on it. So I washed it in diesel fuel, then cleaned it with a special degreaser. Well, this kind of stuff basically dissolves oily deposits really well. I cleaned out all the channels, washed off the diesel and blew it out. So I also unscrewed the plugs. You can see we have these kinds of plugs here. This is how it screws in, and inside we have a drilled oil passage. So, as I mentioned in the previous video about the Volvo engine, about repairing the Volvo engine, under this plug there was a lot of buildup, specifically this compressed black dry dirt. That's it. So I tried to scrape it out, but it wouldn't come out. I had to drill it out with a drill, basically remove it that way. Cleaned all of them out with an attachment. 543. So that means another 33 grams. 5 grams, 38 grams, the difference. The maximum difference in piston weight we have is 38 grams. Well, we see that this piston has for the difference. So I've already installed the pistons on the connecting rods, checked the piston ring end gap, and installed new bearings, connecting rod bearings, as well as main bearings. They're from Case and Combo Schmidt. So I've already installed the sleeves in the block. For now, just without the seals, I installed them and measured the protrusion of the sleeves above the cylinder block. Here we also have a somewhat interesting sleeve design. Well, I don't know how well you can see it on camera. Basically, this spot here has a sort of spherical profile, and it turns out the very top of this profile, the very top, I took measurements on all the liners, and the protrusion of all the liners is exactly 1800. So everything is fine here as well. Well, we didn't do anything with the block in this area. I mean, during the rod removal. We didn't do anything, and we also didn't do anything to the liner seats. Also, on the Soxer, and the old liners also didn't have any adjustment rings. So we just installed new liners instead of the old ones without any changes. Alright, so now I'll take out the liners and unpack the sealing rings that came with the piston kit. I'll unpack the rings, install them, and then install the liners into the block. And I also plan to install the pistons in place today. So we see we have 4 rings, 3 thick ones and 1 thin one. Out of these 3 thick rings. One has a different color, kind of purple, and it turns out this ring is placed closer to These are defects specifically in the seating area for the ring. So I installed it with sealant and tightened it. So I want to show it with it tightened down. As we can see, the gauge reads 0. So the gauge reads 0. Well, it goes up to about 1800s. Moving on, the gauge reads 0, and it also goes up to about 1800s. Not 0. Well, here it's about 1716. Let me remind you, it should be somewhere between 1420. We also see 17. 18. 18. As per the stage. So I installed the sleeves yesterday, left it overnight, and now I'll try to unscrew each sleeve one by one. I remove these clamps, insert the piston, and then probably put the clamps back in place. I still have a lot of engine work to do. Well, I mean, there's still a lot of work before I install the head, so I'll keep the sleeves clamped in a secure position. So, I want to briefly explain why the process of installing this particular piston took so long. Basically, the oil tubes, or rather the oil nozzle, and the connecting rod, when you insert it, part of the rod hits the counterweight and part of the rod hits this tube. So, it feels like the oil nozzle should be installed only after the connecting rods with the pistons are already in place. Only then should the oil tubes be installed. I wasn't sure, but I had to slightly turn the connecting rod, rotate the crankshaft, insert it there, and then, well, I don't know, I'll try on the next one. But this one should be easier because there are no counterweights here. So, the marks on the bolts, that's from when the connecting rods were being machined. The machinists made those marks. I'll wipe them off with solvent now and put my own marks. Alright, so I'm continuing the assembly, and now I'm working on the timing system. I'm figuring it out. The system here is actually quite interesting. I'll try to explain it briefly. So, this is the crankshaft gear, and there are two intermediate gears, or actually, you could say three. These three gears are all intermediate. And from them, the drive goes to the equipment here, and over there it drives the camshaft. So, what's the peculiarity? This cover isn't centered on the block in any way. That is, there are no guides, so it can move around like this. But these two gears are centered relative to this cover, so you can't move them. So you need to center this cover in such a way that these gears have thermal clearance, like this, about 1/10 of a millimeter. I looked up how to do all this on the internet and made these two, let's say, guides or jigs. Basically, there are factory-made guides like these, but the system there is like this. An additional cover is attached to this intermediate plate, this cover, and the cover itself is attached to the plate through the guides. So, the diameter of these guides is 17.8, and when you remove this cover, you need to screw into little barrels, basically the same kind of guides, into these spots, and they are simply tightened with a bolt. Temporary guides are installed, and some work is done with the block. The cover is removed there and the timing mechanism is disassembled. But these guides are temporary. They can't be removed. They should stay installed on the block. And only after this intermediate plate is installed during assembly, and only after all the bolts securing this plate are tightened, only then can you unscrew and remove these temporary guides. I looked all this up in the literature, found the correct part number. We searched for these factory guides by their number, but they are not available anywhere. Well, in general, I also looked on the internet to see what people are doing, homemade stuff like that, different things. So, basically, I went the same way, machined two bolts like this, screwed them in, installed this cover, for now without any sealant. We install it without a gasket, just with sealant. I screwed on this cover, tightened it, and installed these gears as well. Tightened them too, just to check, to see how everything would fit together. So, we can see here we have a gap of about 1/10, and here the gap is about 1/10 as well. But this gear here, it turns out, doesn't get centered in relation to this plate at all. That is, it moves like this, it has this kind of play. Right. And it needs to be tightened only after the head is installed, after the camshaft is installed. And it turns out you also need to maintain the gap, here 1/10, here 1/10. Well, as an option, you can just insert a feeler gauge here, and with the gauges in place, tighten these bolts. Also, while I was working on all this, I came to the conclusion, based on what I've heard from several sources, that you shouldn't grind these heads on a surface grinding machine. That is, the machinist told me that you shouldn't grind them, because after that you can't adjust the clearance at all. Well, also I've heard from other sources that you shouldn't grind this head either. So, I haven't gotten to the point yet where I'll be installing the camshaft and checking, adjusting the clearance. But as far as I can see, with the play we have here, these are the intermediate gears. So, for example, setting the clearance to 2 or 3/10 of a millimeter doesn't seem like a problem at all to me. Well, these are just my preliminary thoughts for now, until we get to the point where we install the camshaft. I'll have a clearer understanding for myself there, whether it's possible to adjust to clearances of, say, 0.3, 0.4, 0.5 millimeters or not. Well, for now I believe that adjustment is quite possible. Why not? We have quite a large margin for adjustment from the gear mounting. Also, I want to say that it's a very interesting system. So, there's a shaft, oil is supplied under pressure inside the shaft, and there's a channel for each shaft. And from this shaft, oil is also supplied under pressure to the gear itself through a bushing, all three gears. And also, right here we have an oil nozzle installed, which is also an oil channel, and it has a hole drilled for each gear. So this is a very well designed, reliable timing mechanism on this engine. So what am I going to do now? Now I'm going to remove all these gears. I'm removing this intermediate plate, unscrewing these guides, cleaning everything, degreasing it again, applying sealant. I have a good sealant that I've been using lately. I really like it. So I apply the sealant, then I install this plate, tighten it, put these two gears back in place and tighten them as well. For now, I just set this one roughly in the middle position. I tighten it just a little bit because, as I said, we'll adjust it later. But I tighten it up, then I'll probably install the oil pump next, and then I'll move on to installing the cover and the flywheel. I'm closing the oil pan, then we'll install the cylinder head, probably in about 2 days, though I'm not sure exactly when. There isn't much work here, but since this is all new to me, I have to figure things out as I go. All of this, first I have to think it through, understand it, and only then start assembling. That's how things are going for us. We're continuing with the engine assembly. So as we can see, here's the oil channel. It comes out of the block, the main line, and then it goes to one shaft. Here we have the mounting for this gear shaft, which is with 6 bolts arranged in a circle. The channel goes to the second shaft as well. We can also see the mounting with 6 bolts, and it also goes to the third shaft for the gear mounting. Here we have the oil nozzle that I showed earlier, so oil also goes here to the nozzle. We'll apply sealant here along this area around the perimeter, and we'll also apply a thin layer of sealant along the oil channel. Alright, so I'll degrease it and apply the sealant. It looks like I got a small dent here, probably when the block was being moved. Now I need to carefully smooth it out with a file. So I installed the gears, tightened the bolts and applied thread locker. I just tightened this one for now, adjusted it a bit like I said. I also installed the oil nozzle that lubricates these gears. So next I'll unscrew these homemade guides of mine. Well, and then I was going to install the oil pump. So about the oil pump, I took it apart to see what condition it's in. So we're keeping the old pump. I'm going to assemble it now and coat the gears with assembly lube. I also removed the intermediate gear, and there's this kind of wear on the bushing itself. Well, and the axle itself also has these kinds of scratches. So on the previous Volvo engine I worked on, I also had to replace this gear. There I think we replaced the bushing and the axle. And it's the same with this engine. We can see that the lubricant goes through this hole. The lubricant goes directly from the oil pump into this hole. Well, then it goes here onto the shaft. And then it gets onto the bushing itself. So it turns out that the lubricant goes directly from the pump. It doesn't go through the filter. That means the oil is unfiltered. If something gets in there, scoring happens right away. This is what the gear looks like in this condition. And it's right along the oil passage. So I ordered new gear and shaft. They'll be here in a couple of days. Well, basically, I still have some time. For now, I still have things to do. Let's wait. I'll assemble the pump now. I'll install this cover. I'll install the oil pickup. Well, and then we'll wait for the gear. So I installed the cover, tightened it, it just goes on with sealant, no gasket. So as you can see, the cover is without the oil seal. The oil seal is this big. It's 180 by 205. So as you may remember, during the last Volvo engine assembly, I also struggled with installing the oil seal. Well, because whether they come in a gasket set or separately, they come without a guide sleeve. For those who know, there should be a plastic guide that comes with the oil seal. So you can easily put it on and it doesn't get bent like this, specifically with Volvo, no matter how many we've bought. And right now we have an Erling gasket set. It comes with an Erling oil seal, but it's also without a guide sleeve. So what did I decide to do? I decided to install the cover first. And now, just like this, use my hands to fit the oil seal and then tap it in with a drift. Basically, this method works. Sometimes I replace oil seals on a Mercedes right on the spot, for example, in a service pit, right on the engine. That's it. I fitted the spring like this. I know for sure that the spring is in place and hasn't bent. And now I'll carefully seat it all the way around. And that's it. So, I've installed the cover and the oil seal. Basically, this is a good working method, much easier to install than last time when I struggled and installed it without an installation tool. That's it. The cover is tight, all bolts are secure and the sensor bolt is screwed in. Next I'll be installing the flywheel. The flywheel, clutch cover and disc remain unchanged. I cleaned it, installed a new bearing, cleaned the disc, blew it out and got it ready. I also cleaned the clutch cover, blew it out and got rid of the dust and dirt. I also prepared the bolts and the flywheel mounting. Everything is ready. So I installed the clutch and tightened it. I put all the studs back in place because when I removed the gearbox, the nuts came off together with the studs. So now I unscrewed the nut from each stud. It was rusted. So I cleaned the threads on the studs, I cleaned the threads on the nuts, screwed all the studs back in place, put the nuts on, and now everything is ready here for installing the gearbox. So ideally I should put the oil pan on now, but as I recall I don't have the gear. Well, the intermediate gears for the oil pump, I just put the cover on for now to see what bolts I have. So for now I temporarily put it in place. So we're waiting for the gear. The gear will probably only be here in 2 days. So I have 2 days to do something else for now. Then the gear will arrive, I'll install it. I'll immediately put this hub on the crankshaft. Well, and then I'll immediately put this cover on. And all that's left is to install the oil pan. Well, there are still some small things. So what do I want to do now? Now I want to turn the engine like this under the hoist and install the cylinder head. So the head is ready. The head was repaired. I wasn't the one who worked on the head. The head was sent to an outside organization. Basically, we were deciding whether to grind it on a surface grinder or not. We can see there are some pits here, corrosion. So we decided not to grind it and just leave everything as it is, what work was done on the head. The valve guides were replaced and all the valve seats were replaced, 12 in total. The valves are still the old ones. I would still recommend replacing at least the exhaust valves because there is wear on the stem. Well, in general, the customer gave it to a third-party organization. They handled everything there and already sent me the finished head. So now I've cleaned it, degreased it and blew with compressed air. Well, basically that's it. I've checked everything. Now I'm taking out the gasket, hanging the head on the hoist. So I need to hook it from that side. Alright, so I've prepared everything for installing the head. I turned the engine, like I said, under the hoist. I've installed the guides. Now I'll remove these clamps that are holding the sleeves. I'll blow everything out, wipe it down, then we'll start installing. So the cylinder head is already prepared as well. I've blown it out several times already. I hooked it up like this. And the bolts through a large washer onto the chain. So I also prepared the bolts. I washed, cleaned, blew them out and measured them. The gasket we're using is from the Erling set. So in the set we have an insert. We torque them to 60 Newton meters. Then we torque them to 60 again. Well, the gasket is one piece. The head is large. We start from the middle. When we get to the outer bolts, the middle will loosen a bit again, so we'll need to tighten it to 60 again. The middle bolts should give a little more, tighten up a bit more. Then we tighten with one 90-degree turn, and then a second 90-degree turn. That's it. So that's our tightening sequence. So I've installed the cylinder head and tightened it. Next, I'll work on the injectors. And the injectors were repaired by the fuel injection shop. So this is what they look like. So what's my task now? Replace the rubber seals. We see that we have 6 of these little packets in the kit. Each one contains a full set of seals for an injector. Replace the rubber seals. Next, let's install the injectors. Here I've already prepared the retaining clips with bolts. And also the injector. The ball is inserted right here. Here's the ball. This is what it looks like. And so like this. The follower, so to speak, first the ball is inserted. The follower bears against the ball. And then this follower bears against the adjustment screw. So I rejected 3 of these followers. Well, you can see the wear here. Maybe it's a problem with oil supply. Or maybe it's just wear over time. Here's the first one and the second one. And the third one. Well, for comparison, this is what a good lifter looks like. And this is what a worn one looks like. It turns out we have 3 of these lifters from Bosch. As you can see, it comes with a ball. And also the matching part. The adjustment screw, which is installed directly in the rocker arm. We'll also have 3 new ones. So now I'm installing the injectors. Next I'll be installing the rocker arms. Well, actually all these valve bridges. Here we also have these, what you call them, barrels. They go on to the adjustment screw. And this barrel presses against the rocker arm. I'm assembling the rocker arm, installing the rocker arm shaft, and then I'll install the camshaft. We're keeping the old camshaft. There will be a replacement of the bearings. Also the camshaft bearing saddles. I already have all of them there. They're also cleaned and washed, lying on the shelf. So right now I'm working on the top part. There are the rocker arms and injectors. And then I also need to assemble the compressor today for sure. Replace the pumped air. install a new water pump. Also, I still have something that hasn't been cleaned. There's an intake manifold over there that hasn't been washed. The hydraulic clutch will be replaced there. In general, there's still a lot of work to do. I'll finish all this now and then get back to washing. Until the end of the day, until the evening, I'll be busy washing. Alright, that's the amount of work we have. Let's get started. To be continued. Alright, so I've installed it, tightened the injectors, all the valve bridges. So a bridge with a pad is placed on the intake valve. This kind of valve bridge with plates is placed on the intake valve. So later on we might still need to adjust these screws, but we'll get to the adjustment later. Next I'll be installing the camshaft. We're keeping the old camshaft. I washed it, blew it out and inspected it. It's actually in excellent condition. As for the camshaft, there are no issues. No issues, as you can see. There are a lot of marks here. I'll explain later what they're all for. So each valve is adjusted according to its own mark, and in general the camshaft system here is quite complex. The camshaft has its own main bearings. This part here is flipped towards the cylinder head, and this, as it turns out, is the cover. Also, these saddles are designed for bearing shells. Here we have a set of bearing shells, standard. Now we're going to take them out and install them. We can also see the number of bolts here. Some bolts are long, some are short. Some bolts are screwed directly into the saddle itself. Here we can see there's a thread. Some bolts go all the way through the saddle and also through the rocker arm shaft. The rocker arm shaft is mounted onto these guides. It's not ready yet. I need to replace the adjustment screws there. Basically, I still need to work on it. There are also studs like these here. A stud. On the other side is also threading. These studs, I think, are attached to this side of the cylinder head, like this. And the valve cover is attached to this stud. And these studs also hold the camshaft itself. I think they're installed on this side. And then the camshaft cover is also screwed onto them. So the camshaft system on this engine is really elaborate, convoluted and complex. We also have these kinds of plates. They are attached together with the rocker arm shaft. They're installed after the rocker arm shaft, so I've laid everything out on the table. Now, we'll figure out what goes where, in what order and so on. Well, I understand that if I only worked with these engines, it would already be automatic for me. But since this is my first engine of this type, things aren't that simple and clear for me yet. Well, alright, these are all minor things, we'll figure it out now. Well, naturally each cap is marked, so you can't really mix up the saddle and the cap, and accordingly it can only be installed in one position thanks to the guides. So you can put it on like this either. It can only be installed like this. So as we can see, there are no oil supply holes in the bearing shell itself. Here we have an oil channel in the cap itself, and as a result there's a notch on the bearing shell. So the oil gets in exactly through this notch. And of course this notch is present on every bearing shell, so it doesn't matter which shell goes where. Only the first shell comes with thrust washers. The thrust washer is for axial movement, so it turns out that only the first main journal has a different bearing shell. All the others are the same. So for now I've just put them in place like this. Here I have two caps bolted to the block, and here I've put in two bolts loosely. Now I'm going to remove that big intermediate gear and set the timing marks. I've roughly aligned the mark as needed, but I need to install the front cover first. And then we check the mark using it. We align it with the flywheel. In theory, the timing marks are set here. The flywheel is set to 0, and the camshaft is also set, let's say, to 0, if not to top dead center. And that's it. All the other gears can be installed in any position. I've installed the camshaft. For now, I've only tightened it with lower bolts. Here, it will be fastened together with the rocker arm shaft. So, I've tightened it. I've already pre-adjusted the gear. Well, that's it for now. Later, when I have the rocker arm shaft installed and tightened and the valves adjusted, I'll check the clearances again. And only after that will I unscrew these bolts, do them in pairs, apply thread locker to them, and then tighten them. I've prepared the rocker arm shaft. I cleaned it as much as possible. This is the dirtiest engine I've worked on, and I don't know what those deposits are. I've never seen anything like it before. So I cleaned it, blew it out several times. So I sorted them into groups of 3 rocker arms. Here I took the old seals from the injectors. Well, I just put them together so everything would be grouped. I've already installed these shims. I applied assembly paste there, installed and snapped it in place. So I've already replaced the 3 adjustment screws that go on the actuator. This is the injector one, the one that does the pushing. I'll show you what it looks like and how it wore out. Like this. So here are the cylinders, the 6th, 4th and 3rd. We have new adjustment screws installed, and accordingly I also mark the 6th, 4th and 3rd on the injectors. I will install new tappets here. Now I'm installing these injector tappets, then I'll install the rocker arm shaft, and then we'll start the adjustment. The intake valve will be adjusted, the injector preload will be adjusted, and the exhaust valve will be adjusted. The exhaust valve here also has a hydraulic lifter. It's a jake brake system, so there are a lot of nuances. I'll explain everything now. But before we install the rocker arms, we need to adjust these bridges. That is, we've loosened all the adjustment screws. Well, more precisely, I unscrewed the lock nut, screwed the adjustment screw, and basically this way we tighten the bridge all the way, screw in the bolt until both valves make contact, and after they touch, we turn it just one more flat and lock it with the lock nut. We do this for all of them, but this is our bridge, and this bridge moves along the guide. So if there's any misalignment, the guide will rub on one side, E, and it could even break there. Or there will be wear, shavings, and so on. So this is also an important point, and it definitely needs to be done. Since our cylinder head was replaced after repairs, everything was done, the bushings were replaced, and so on. The valves might have been mixed up in places. So I adjust the bridges, then install the rocker arm shaft, and then we start adjusting the intake valve. Everything is clear. Lock it with the screw, set the gap, lock it again, and the injector is cleared. Loosen it as much as possible, make contact, and then tighten it another 180 degrees. Well, you can do 180, 180, 240, but as I understand it, 180 is quite enough, or maybe a bit more, like 190. When it comes to adjusting the exhaust valve, things are a bit more complicated. Here everything is adjusted with these shims. You can see the size on the shims. 200, for example, means 2 millimeters. Here, for instance, 215 means 2. That's the size in hundreds, 2 millimeters, and 15 hundredths. I don't know, I'll see how it goes, if I can manage everything. When everything is installed in place, I'll adjust, record, observe. Maybe swap some shims around. Or we'll order new shims of a different size. Well, in general, we're going to deal with all of this right now. So we switched the rocker arms around, and I remember the saying, if a person is an idiot, it's for a long time. I don't know why all of a sudden. Okay, I switched the rocker arms. I had them installed incorrectly, so I'm adjusting them again. Continued. So I'm working on the adjustment. I've already turned it and now it's on V2, which means I need to adjust the exhaust valve on the second cylinder. So I took the measurements. Here I can fit a 2.6 mm filler gauge, but the standard is that a 1.6 mm gauge should fit. We can see this gap. So I noted that I need to increase the shim thickness by 1 mm here. And also, for example, on this valve, I have 0.2 mm 1.8, but I need 1.6. The shim thickness needs to be increased by 0.2 mm. Here, it's 2.05. So the shim needs to be increased by 0.45 mm. So these two valves are already adjusted, or rather, the valve and the injector. These are also adjusted, the valve and the injector. Next, I turn the engine clockwise to the next mark. I see there's a 6 there, so I should. When this number, the line for 6, comes out here between these two lines, then I can adjust the valves of this cylinder, or rather the intake valve of this cylinder and the injector of this cylinder. But now, using these two as an example, I'll show you how the adjustment is done. First, we turn it and set the marks. So, the 6th cylinder, first we adjust the injector. For this, we need to loosen the adjustment screw. Unscrew the lock nut and then tighten it. Here, it's come to a stop and you can feel it make light contact. Then it stops, and after this stop, we turn it 180 degrees. Well, there's a bit more tension when tightening the injector. Now we just lock it in place and the injector is adjusted. And as for the valve, basically there's nothing complicated either, we just unscrew it. The lock nut. We take a 0.2 mm filler gauge, insert it between this bridge and the pad, tighten it. There, it's tightened. Then slightly loosen it so that the gauge can move with a little bit of effort. And we lock the lock nut. So the valve and injector are adjusted. Then I turn the engine to the next mark, which will be V4, meaning the exhaust valve on the 4th cylinder. I turned it to the next mark, E, and at this mark we can adjust the exhaust valve on the 4th cylinder. So we see this kind of gap, and I've picked the filler gauges. So 0.85 plus 0.65, that's 1.5, and another 0.55 makes it 2.05. It's a bit tight. Well, basically it's fine. 2.05 is a bit tight, but it goes through. We write 2.05, but we should have 1.6. So that's a plus 0.45. I don't know the millimeter. I'll check which ones I have now. Valve shims are installed on all the valves, so not a single main one is higher yet, and none have been adjusted yet. I haven't thought about it. Maybe it'll work out, but it hasn't yet, so I'll need to adjust them. We can see that all the valves need to be adjusted. All of them need thicker shims. But at least half the valves can be done with my 0, 0.65, 0.65, 0.65. Select, but only for half of the valves. But we need to place an order, so we know what sizes are needed. We'll place the order, and then we'll have to wait for the plates to arrive. Well, then I turn it to the next mark. There, we have a 2, which means on the 2nd cylinder. I adjust the injector and the intake valve again, and so on. So next I'll be assembling the compressor As for the compressor, I took it apart, checked what was needed and cleaned it. We can see that the cylinders here are non-removable. There are some small scratches and longitudinal scuffs on the cylinders, but I think they'll still work for a while. The scratches aren't critical. Well, because otherwise you'd have to either buy a new compressor assembly or put it back together as it is. So, what do we need to replace? We're going to replace the repair kit. Obviously that includes all the gaskets, valves and so on. And we're also replacing the pistons, meaning the set comes with rings. So, you get a piston like this. The piston itself, the pin, the clips, and the piston rings. That's basically it. Everything else stays the same. The crankshaft, the connecting rods, the timing gear. That's all. So right now I'm working on repairing the compressor. I'll be assembling the compressor off camera just because I want to get it done faster. It's already taking too long and the customer is rushing me too. The next one will be here soon. There's another truck in line. So I'm assembling the compressor. Then I still need to swap the pump over there, and I also need to clean the air manifold. Over there I still have unwashed parts. The air manifold, a heat exchanger cover, and several different tubes on the table. There's still a lot of cleaning and work left. I thought I was almost done and would assemble everything soon, but it looks like I'll need another week. So they brought me the intermediate gear. Brought the shaft. I've already installed and tightened it. Also adjusted this gear again. Unscrewed 2 bolts at a time and put them on thread locker. Well, in pairs basically, so it wouldn't shift. I put it on thread locker and tightened it. Also checked the tightness of this gear. So now I want to show that the oil pump, as we can see, has some play. Next is the intermediate gear of the oil pump. There's some play. This is the intermediate gear. There's also some play. This is okay, now this one, the one I just adjusted. So I cut the old feeler gauge, well, so that I could insert it. So that... Alright. Let's take a look. If I insert it here, it goes in kind of tight. That is, as we can see, there's no play here anymore. We still have some play here and in this spot. I don't know how well you can see it on camera, but overall my timing gear clearances are all good. I double checked everything. Now I'll set the marks again. I'll set them on the flywheel. There's an inspection window there. Here on the camshaft I'll check again where its mark will line up. Well, where this mark matches basically regarding the valves. So I've already adjusted 3 valves. This one. Today the shim arrived actually 2.65, so I installed the 2.65 and it's installed 2.15. I ended up with 4.8. Well, not this valve right now. I adjusted this one last time. And I also adjusted this one last time. So I still need 3 more plates. I'll have to wait a couple more days for the plates. They ordered about 10 pieces at once. Out of those 10 I'll choose the right sizes and the rest will just return. So what should I do now? Now I close this front cover. Actually first I install this tray. The counterweight on the crankshaft. Actually, not the counterweight first. First I install the hub on the crankshaft. I heat it up. I install the hub while it's hot. Then I screw on this counterweight. I screw in this central bolt that holds the hub. I close this front cover and then I guess I close it up. There's another cover here as well. It's a small one. I also checked online how to install it because it goes on a rubber gasket. Basically, there are these oval holes there. You need to screw it into the oval holes, then tighten it on one side and align it with the head. So basically there are some nuances too. We'll get to that in a moment. Today I want to install the hub, the counterweight, and close this front cover. And close the oil pan. And maybe even put the engine in its working position. So I installed the oil pan. I did it off camera. Last night I cast a little with this oil pan, so I decided not to include all of that. I decided to skip all the details here. I'll just say one thing: the gasket is very inconvenient. The installation system is really awkward. Well, it's specifically the way the gasket fits onto the oil pan, and then these aluminum rails are installed onto the gasket. Well, I don't know who came up with this, who thought of something like this. Created a miracle. It's the first time I've seen something like this, and honestly I never want to see it again. Anyway, the oil pan is already installed. Next, I'll go ahead and install the front crossbar, or whatever you want to call it. Basically, it's the mount that attaches the engine to the engine mount. I'll put the plug in here. I'll clean it now. Then I'll install the pump. So basically I'm starting to install some of the bolt-on parts here. Also, I've already received the valve adjustment shim. Now, maybe I'll close up the intake manifold first. Then I'll adjust the valves. Basically, I'm assembling as I go. I'll see what exactly is best for me to do right now. So next, I'm closing the upper front cover. I washed it, cleaned it, and blew it out. I also replaced the gasket here. This is the kind of gasket we have here. It's rubber. And what's the particular feature when installing this cover? What happens? We need to align this upper part with the cylinder head so that the valve cover fits properly. And we have to somehow press and squeeze this gasket. So we turn the cover over and see that we have two oval holes. 1, 2. So we put the cover onto these two bolts, almost tighten them, and then use pry bars on each side to press and align it flush with the cylinder head. So that's the feature here. Well, what can I say? That's just how it is. That's what it's called. Of course, the engine is interesting. There are a lot of design choices here that I've never seen in all my years doing this. There are certainly a lot of interesting solutions, but also a lot of really complex ones. For example, the oil pan mounting, those same rubber seals and so on.
Procedure 3 to be continued.
So, I worked without the camera for a while. In a few words, I'll tell you what was done. I installed the intake manifold. I decided to install all the electrical components right away. So I installed the control unit, installed it, and laid out the wires. I had to wrap the wiring for the injector with electrical tape. The insulation was already damaged here, leaving wires exposed. I connected everything and tightened it all up. I also adjusted the valves. Here, as you can see, it worked out. I marked which shim thicknesses go where. 4.6, 4.8, 4.75, 4.7. On the second cylinder it's 5.25 or something. On the first one it's 4. I rechecked the valve adjustment by rotating the engine to the timing marks. I checked the intake and exhaust. So I'm done with the valves too. I can put the valve cover back on. I just need to screw in the studs for the valve cover here. And basically that's it. My valve cover is already ready as well. I washed it more than once, probably even more than a dozen times. I also installed the power steering pump, installed the fuel pump, and laid out the fuel hoses here. I installed the filter housing. You could say I've pretty much assembled this side. I still need to install the temperature sensor here. Basically it's broken. I'll leave it loose for now and start painting. Then after painting, the sensor will probably arrive. I'll have to remove this cover here, remove the jumper there, and install the temperature sensor. But that won't take long. So now I'm putting the engine in its working position. Well, and I'll probably close the valve cover. And I'll start assembling from that side. On that side, I still need to install the heat exchanger. Close the cover. The compressor there has been repaired. The pump. Next. The turbocharger is already prepared. After repairing the manifold, I also have the manifold bolts painted. They are also prepared. Well, in general, there's still a lot of work to do. If you look at the shelves, all of them are still occupied with something. I assembled the engine without the camera and installed everything, including the filters. I installed the rocker assembly. I closed the valve cover, the filler neck. Here's the breather. So I installed the compressor here. I showed the repaired compressor, what had been done to it and what had been replaced. I installed the pump. Also, the pump itself is new. This part here gets replaced. Basically, with the bearing and the impeller, this housing stays old. I installed the coolant filter, which is the first engine I've seen with one, and the fuel filters too. 3 of them. And I also installed this valve on the engine brake. As for the engine brake itself, I didn't do anything with it. I just didn't have enough time. At first, the customer told me that it was hissing somewhere, so I need to check it out. Maybe it's this valve, or maybe it's the damper itself. Well, and then, when the customer told me, I just physically didn't have time to do all of it. Because customers are always in such a hurry, faster and faster, but the amount of work involved can't be done any faster than I can do it. That's just how it is. So that's why we didn't do anything with the engine brake. Everything stayed the same as before. So what's my task now? I'm gonna prepare the engine for painting, but as usual, I block off any other openings that need to be plugged, like here, and so on. So I block them off, paint the engine, and wait for it to dry. Pet, D12. And today I definitely need to install the air manifold, or rather, the exhaust manifold, together with the turbocharger. It's already over there on the shelf, prepared and ready. I've shown that I installed and repaired the turbocharger and painted everything with heat-resistant paint. So that means I definitely need to install the manifold today. After painting, I definitely need to install the new fan clutch. I'll show it later. I replaced the fan clutch there. I also need to install the belts, because once the hydraulic clutch with the fan is installed, there's no way to replace the belts. Well, I don't know, maybe it's possible somehow, but it will be really problematic. So today I need to put it on the pallet, because tomorrow morning it will already be installed on the car. And the person who's doing the installation is probably planning to work with this engine all night. So basically we only have a few days left to finish assembling it, so to speak. Also, the transmission will be installed separately. First, the engine will be installed in the car, and then the transmission will be installed. That's it. So we won't have a lot of filming right now. I'll quickly paint it, get it ready, and that's all. Then, everything will go as I said. So the engine is ready. I installed the turbo, the manifold, and somewhere here the air intake for the compressor is still unpainted. Well, basically I installed all the small stuff. I forgot to put this plate here, so I struggled with it, had to unscrew some bolts. I installed a new hydraulic coupling, tightened and installed the protection. That's it. The engine is ready to be installed. I installed new belts. The customer asked to remove the AGC, so we put on a shorter belt just from the pulley to the alternator. I tightened it here and basically everything is good. I installed a new tensioner pulley and also put this belt on the hydraulic coupling. Well, and as I already said, we won't have AXC here. So now the repair cost of this engine will appear here in subtitles. If I don't forget, I'll specify it. So basically I'll be wrapping up the video about repairing this engine. Next we might have, or at least we should have, some footage of starting this engine already in the vehicle. I'll try to film it. Or at the very least I'll try to film the engine already running when it's installed in the vehicle and started to show how it works. That's it. So I'll be wrapping up this video. Thank you all for watching. Good luck to everyone and goodbye. engine has warmed up. We can see the oil temperature is 81 degrees. The gauge reads, well, less than 4, it's about basically around 3 here. It's hard to tell, right? We don't have a scale, but it's about 3. This is at idle. So as we can see, idle is at 550 RPM, and the needle is somewhere around 3. The engine temperature is already above 80. Well, the oil temperature is 81 degrees.